The purpose of this screencast is to show how to use steam tables to determine the properties of water given two existing conditions. Take the following example, where pressure and internal energy values are reported for water. We want to determine temperature and specific volume of the water given these conditions. We could also determine the quality of the steam, which is the fraction of the liquid-vapor mixture that is vapor. The first place to start with any kind of problem is to write down our knowns. In this case, we have a pressure of 0.3 megapascals and a specific internal energy of 3,000 kilojoules per kilogram. Then we could write down our unknowns for this system, or what we are trying to solve. In this case, temperature in degrees Celsius, the specific volume in meters cubed per kilogram, and Q, or the quality of the steam. The approach for the solution includes a knowledge of the Gibbs phase rule. Since we have a single component, that of water, this could be either pure vapor, pure liquid, or a mixture of the two. We know that we have to define at least two state functions. These two fixed state functions are given in the problem statement, that of pressure and the internal energy. Therefore, using the steam tables, we could define everything else. Using a pressure of 0.3 megapascals, we can see that for saturated steam, the internal energy is 2,543 kilojoules per kilogram. Since the saturated value is less than the given value in the problem statement, we know that we must have superheated steam. We could use the superheated steam tables to try to figure out what our temperature is given the pressure of 0.3 megapascals and the internal energy of 3,000 kilojoules per kilogram. Looking at the values of internal energy as a function of temperature, we see that the stated internal energy falls between 400 degrees Celsius and 500 degrees Celsius. Therefore, we can linearly interpolate between 400 degrees and 500 degrees to figure out what that temperature is, given the specific internal energy of 3,000. We take the defined value, 3,000 kilojoules per kilogram, and subtract out the minimum value in our range, and then divide this by our total range of the system. Set this equal to the same setup, but for temperature being the unknown, we solve for the temperature, which in this case is 421 degrees Celsius. Using significant figures, we will report it as 420 degrees Celsius. Using the same setup, but in this case for specific volume, we solve and get a value of 1.064 meters cubed per kilogram. Again, using significant figures, we will report that as 1.06. The last thing was the quality of the steam, and since we know it is superheated, that quality must be 1, meaning that it is pure vapor. There is no liquid water in this system. At this point, it's good practice to check the units, make sure we've boxed the answers that we're looking for. The three unknowns we were trying to seek were temperature, volume, and quality, or Q. Temperature reported in degrees Celsius matches. The specific volume in meters cubed per kilogram matches, and quality being a fraction has no units, so that's all good. Therefore, hopefully this example has given you an idea on how to use steam tables to determine parameters of a water system given enough state functions to solve.